Yes, it's me. Oh. Where's my face? My face is gone. No. Wait. Ah, here I am. Second maker in the village. It's Saturday. The weather is bad, which is perfect for streamers and YouTubers because people stay at home and watch streams and videos. So, how are you doing, my friends? Hello Johnny, hello Dutch, hello Jumbo. Hey GK Bat. Hey Sonic. Nice to see you again. I did some work off stream, but only a little. Excavator, yes. Excavator fund is... where is my excavator fund? Here, go fund me. Let me turn on the camera though for this part. Beep. Here we go. Hey Henrik. Hey the Sheepu. You also found some time to join the stream again. Alright, so I was able to take it apart a little bit more. I had to detach some wires, of course, from the speaker and the battery compartment. It was quite tricky, like, to get off this part here. Hey Roman, welcome to the stream. You made it. Oh, wait, where's my box with the parts that I... Ah, here. I should be... I already lost the screw, but I'm trying to keep all the parts together from the device to... Where else? I'm streaming on Twitch and YouTube at the same time in parallel. Twitch tries to shut this down, but I don't care. Report me, then Twitch will be shut down and we continue on YouTube. Here we go. Hey Z80. Hey Adam. It's hot, what? Where are you? Oh, Adam. You're not in Europe right now. Central Europe is like... We're full again. Alright, so... I, last where we left off is trying to decode the TRS remote. I found even... Yeah, the winter's coming. I even found TRS, the small one, connectors. What? UK? Yeah, UK. Yeah, I will show you how it looks like for 10 more days. What? C80, what's going on? Yeah, oh, Spain is also hot right now, huh? Let me show you where we are currently. What the fuck? Here. Alright. South Europe fires. Alright, look at that. 17 Berlin, 17 degrees C. Okay, I see that. You have some sun. You're not used to having like 28 degrees here. Also, Dublin looks nice. Greetings to Brian over there. Z80. Oh yeah. But it's moderate. It's not 40 degrees C. I mean, it's already evening. But what else do we have? France. Oh yeah, you can see here. There is where I am right now. So My grass can grow now because it was drying off. I seeded new grass patches with my terraforming project, and when it was hot, I tore my back yesterday. I bought two new solar panels, $75 each, just at the company, like it's a solar company next village over. So I just called, can I come over and buy panels from you? He said, yes, you can, I'm there. We just got a new container of panels. It's 70. Hey Peter, greetings to Boulder. And he said like $75 each. And I just hopped on my car, like the Ford, which fits solar panels barely. Drove over. It was like, I don't know, 15 minutes to pack them in, go back, put them on the flat roof of my shed, and now I have like 900 watts more of power, which is recharging a battery. Not today, as you can see, quite cloudy, but it was a matter of 1 hour to get 900 watts upgrade for $150, which is all right, I guess. I mean, I can set off my costs. I have the batteries anyways, some improvised. So, this Endure battery that I made an ad for died during the winter. It was like basically was drained completely, and the BMS refused to recharge it. And since they have like 5 years warranty, that's what I was also like advertising. I just wrote them, battery is not charging anymore. And there was like a back and forth for, I don't know, 2-3 weeks or whatever. They wanted to see my receipt or whatever, and I said, I have no receipt. That was like a review unit. And basically they sent me over a new battery, and then because I have like removed the battery from the solar system, it was like 1 kilowatt hour. It's not big of a battery. Removed it from there, packed it into the original packaging, and waited just for a shipping label, so I will ship it to them back and receive a new device. They just sent me a new set, the control unit and the battery. So after I received the replacement unit, I just opened up the battery, tried to recharge it with my bench power supply. It was like the complete pack, which is like 48 volts, was at 15 volts, which is super low. It's basically, the BMS wouldn't like even probably start or whatever. Yeah, and then what I did, I bypassed I checked the individual cell voltage. Not it's lithium iron phosphate, so it's more durable than lithium iron. There are no like puffy or anything. Prismatic though, but I checked the individual voltage. It was, what was it? It was above 1 volt. Yeah, that's basically where they completely shut off. But it wasn't like catastrophic. So I just hooked it up and charged it slowly. First like to 20 volts. BMS still refused to open up. And then at 30 volts it was also refusing. And then around like 40 volts or something, it refused to charge. Then we just recharged it to, I don't know, 44 or something, 46 volts. Not sure. Yes, it's certainly too low. And then because my friend was visiting, I told you that about that on Wednesday. And this way, like, we connected a new battery to the system that charged well. and then I replaced it by the old battery, which we recharged. It was showing up for like 30 seconds, then it shut down again with an error. I don't know why. Probably there was like something cached because it has some logic to it, and it's communicating with the main unit, like the battery. It has like a controller board. So it's some sort of smart. You can even update the firmware of that. So the firmware was outdated on the battery, but it would shut down like after a few seconds. So what we did is basically we connected directly, like you can daisy chain the batteries just by stacking them on top of each other. They have like a connector which would just stack. So we took like directly connected was the new battery, and then we just put it on top of the old battery. And first it wouldn't show up, or it was showing up, but the charging stopped because probably what happens they're put in parallel, so they're trying to balance each other out. Oh yeah, we charged them, I think, in the beginning to recover some voltage. It charges up very quick in the voltage. I think I even started with 100 milliamps for the whole pack, which is like one kilowatt hour. So is it 0.1 C? Yeah, probably. And then we just increased. I think after 24 volts, that is like 2 volts per battery or something. I don't know. We increased that power. And when it was alright, so I started slow to not damage it as well. So I guess that was a good choice. Anyways, so what I guess it's drawing power, and you could set it up, I think, to 5% or whatever, and then you have like Dunkelflaute in Germany during winter. It wouldn't during the day below 0 C, it would refuse to charge. Lithium batteries or like iron phosphate batteries, they have like their temperature controlled. They won't. I think they even won't charge under like 3 or 5 or 3 degrees C. So during the day they wouldn't charge because it was too cold, but it was also like very low sunshine. That's why probably the shed never went above 0 volts or whatever. Why it was still powered from the battery during the night or whatever. Yeah, something happened there, and probably like the BMS board drained it as well, like really slowly during the winter. We had a long hard winter, and I didn't like bother to take it like in the basement or whatever. It was like out there in the cold, so probably my fault to some extent. But they advertised it like sitting on the balcony. Come on, so. You're taking it inside for the winter. You can't use it during the winter. What is that? Usually, probably there might be like even batteries that heat up, like in cars, but in that case, it's not what was happening. Anyways, so we stacked the 2 batteries on top of each other, and there were apparently the user interface doesn't tell you anything. It would basically, the charging would shut down from the solar, and they were sitting there. The system would recognize its 2 batteries, and then we just left it for half an hour, and at some point probably the charges were balanced, and it started like acting like a 2 kilowatt hour battery now. So it's actually working. I set up protection so it wouldn't discharge below 20% because I'm suspicious of the old battery. I really don't want like to. I like it to train it back to its state. I don't know if that works or not, or what happens there. It's put in parallel, so it's not that bad. In serial, it probably would do more harm. If it's not like heating up or whatever. But you can certainly see it might be. I can show you. So I'm not discharging. So currently it's shut off because it's discharged. We had like no sun whatsoever today. Show that. Okay, here. Its battery is 20%, and we can see statistics. Yeah, it did 1.15 kilowatt hours today. Probably not even, because I think, let me check date yesterday, or we didn't have a lot of sun this week, but I saw already, wait, I saw already, come on, can we see that? Yeah. Did it even charge up? Did it discharge? Yeah, produced 2.4, maybe from battery home usage. Let me show input. Yeah, it is actually, you can see here, it was, I think, was it 100%? Can't tell if it was up to 100%, and what it charged was 1.3 kilowatt hours, and it's only discharging to 20%, so that's 400 watt hours that we protecting. So it lost maybe 300 watt hours, so almost a third of its capacity. If is it how it's calculated, I don't know, probably it's never like the full capacity. So yeah, anyways, it still works. Yeah, and I updated the firmware as well of the old. Or I use my switch, my solid state relay, to just if I can't use the solar, I will just switch it to heat up the whatever, just the wire, and then heat it up. we can control it with, or I would just put the batteries inside of the house. For SSR, but AC SSR. Broke somewhat, loses 10% charge a night. Yeah. Yeah, probably like internal. Oh yeah, I can show you what might be causing some issues. So you can see, I mean, the battery on the this is like the old battery. It's warmer than the new battery on the top, but so I guess there is like some inner resistance or whatever causing to heat it up or convert like some of the power to heat. Yeah, so oh wait, sorry, here you can see the 21, 22. But also it could be that it's just protected from the ambient temperature, since it's sitting underneath the new battery. So that might also explain explain the difference in temperature. We could, you know what? Can we see the stats? Hydrogen, yeah, no, not doing that. I'm wondering if it lost charge. It doesn't look like it loses charge during the night though. Look at that. So it seems to be fine, like keeping the charge during the night. It's a flat curve there. Anyways, so back to our project. Where is it? Here it is. So I tried to we tried to like find out how the remote is working. I found a seller of the remote for like $30, but it wasn't worth it buying, because yeah, we weren't able to debug it, and there is also what was the shortcoming of the remote? There was one thing that you can't do. Yes, using the remote. Power meter devices. Yes. Everything will be controlled, but probably I'm so bad at timing my projects that I will probably be doing it during the winter where it does nothing. I'm getting hot now from all the talking. Here we go. Oh, I strained my back with the panels. They are so like clunky and heavy. What was it? 30 kilos, and then just putting them on top of the... Anyways, yeah. So I managed to disassemble it even more. So if you're interested in looking how it looks like internally, this is the whole device. This is not the processing unit. There is like a blob for the screen. This here is the motor controller. I checked already. Yeah, the 80 there, it costs nothing. You just spend $70. You get 450 watts. This costs not. It's free. It's free energy. It's a free energy device. So here, it's a motor driver, because this is actually this is a stepper motor. So not a DC motor, which is really cool. Stepper motor, and I didn't check the other parts. This is probably like the main processing unit or something. I'm not sure, but it's interesting. Here there was the speaker around this part, and I'm wondering what all those parts are. I'm also wondering, yeah. Yes, I mean it's Olympus, so it's basically camera company. Here you go. You can check the part numbers even. Quality should be all right. Wait, can we see this part number? I might try to. Let me get a torch. Where is it? There's no torch. Here it is. Here we go. So what is it? AN6223S. AN6223S. What is this chip? There isn't data sheet. But it's very slow. Let me check this one. Panasonic. Oh, come on. No! It can't load the data sheet. It's only discontinued. If anyone can find anything, AN6223S. Anything on that chip. ST.com has a PDF, but not the S version. Oh wait, I found something. Huh? Wait. 622. What is this? This is completely something different. Just package, yeah. Did you find anything? All data sheet. Did you find something? Application note. Oh, it's an MCU. Ah, yeah, right. Okay. Anyways, hey, I'm aboard. So there is like a lot of capacitors, there is like some diodes or whatever, regulators, maybe logic gates. Is this flash or something? No, that's probably drivers. Oh, you can't see anything. Here we go. Here we have some audio drivers. This is the connection to to basically the speaker. This is the battery. This is the microphone. And these were the buttons. The buttons we decoded last time already. So we are currently it's in an odd state because this will be our future data storage, tape data storage. Currently it's engaged, so I can't open it. Probably powered it off during an inconvenience state. Dataset, yeah. Now I wanted to decide which MCU to use. Yeah, unfortunately it's not. I could try to, let me check if I can get seekic.com has linked datasheet download, but it doesn't, it triggers. Triggers only a script. It seems it's also related to 6215. Let me check. Oh no. No. Yeah, I was just curious about it. Oh wait. No, it's just the logic I see. Here. Maybe everything is implemented in logic. Is this like dual recording playback amplifier for stereotype recorders? Interesting. It would support stereo even. But I don't think like the playheads are in stereo, are they? Maybe it supports stereo and we don't even know it. Oh, there is a lot of stuff going on there. All right. Anyways, what I want to do is today to control the device with our microcontroller. And which one do we pick? So, do we take, okay, this one is new, unachievable, the 035 USB. The disadvantage, it doesn't have a lot of pins. The advantage is, oh yeah, also probably memory is limited. The advantage is it is 5 volts tolerant, so we could basically like plug it in, power it from USB power, and then have like run it from 5 volts. Otherwise, we can use like the 2.0 whatevers. This is 203, I think. They will be fine. I think 5, 6, and 3, 5, 6. Okay, we need to check the pin configuration of those. And there is the elephant in the room. I'm wondering. Oh yeah, one thing that I wanted to check is what voltage do they support? Is there like a step up boost converter whatever to get higher power, or does it run off 1.5 volts? This would be mad if it runs off. The datasheet that I found doesn't say anything. Oh yeah, it says milliamps. Voltage rating 14 volts. Wait, what? 14 volts. Hey, Dusty Circuit. So do we have like a boost converter somewhere here? I don't see an inductor. Do you see an inductor? Should we check if there is some voltage going on? Oh wait! Here, this might be the inductor. Here in the corner. Here. But what is the boost circuit? So if we can find power that that runs off 5 volts or 3.3 volts and it's boosting up, that would be amazing, because otherwise I need to try to like put there like a DC converter. I measured it needs at least to run at least 200 milliamps to not bug out with an error. How do we measure the voltage? Okay, we can test it. Oops, sorry. We can test it with this here. We need to set up something. It's 3.3 volts. A breadboard power circuit. Come on, this pen is bent. Bench power supply isn't here. Oh, this tripod is driving me nuts today. Sorry. Really? IIL, integrated injection logic. Okay, so where's my DC to DC buck converter boost? Yeah. Where did I put the small DC to DC converter? Oh, I can turn my head. Oh, this is terrible. Oh, here it is. Where is in, where is out? Is it the buck or is it the boost? Here is in minus. Okay. Calculators out plus. Okay, so this is what is, oh yeah, I marked the one with black is minus. Oh, I should measure it first before I try to. Okay, let's turn it on and see what power, if it's a buck or a boost converter. I have the impression that my meter, trusty meter, is dying after 5 years, or how long do I have that? Okay, it's 3 volts, so probably a buck converter. Yeah, 3 volts. Hey, Basil! How are you? Oh, you can get buck boost. No, it only has one inductor. One inductor means only one direction. Let's turn it this way. Oh. Okay, let me turn it. 4.0, it's a boost converter. Maybe it's a buck boost, but I don't. Oh! It's 1.5! What? It's a buck boost? No. It's strange. Oh, it's somewhat. This thing is like really refusing to rotate. Huh? Oh, it's on the 5 volts. Yeah, you're right. Yeah, alright. So you're right. Ah! This is, I feel like this is broken somewhat, this potentiometer, or it's blocked by, sorry. Zero points. 0.7. It's blocked by the inductor. Ah, it jumps right over to. Okay, 1.4 is good enough. All right, let's not break it. This is plus, this is minus, so we will plug it in. Oh no, it came off, damn it. I didn't solder it well enough. Okay, let me fix that quickly. Can't remember where it came off. Huh? Where was this attached? Yeah, the farm remembers. Let me check the stream so I can see where it came off. I just rewind and see. I only see my hand. Oh, I see that. Okay, a little blob to the IC. Yes, I found it. Okay. But I don't show it. I don't want to move the camera. It's just a matter of a second here to solder that back on. Yeah, also recording stuff. You can see how you disassembled it before you did what you did here. Okay, I will use some flux here to have it more safely attached. Okay, I think I have that. Replacing that by a resistor. Oh, maybe we can actually replace it with a... I'm wondering if we can just take off the parts and put it on our own PCB at the end. That might be interesting. Okay, this was minus, was it? On this side, was this minus? Yes, okay. So, here we go. Let's try all or nothing. All or nothing. Haha, it turns on. All right. Yeah, it's working. Display doesn't blink, so it's working. Now we can. This is the audio output. We put it over here. Okay, so that works. We have a DC. Oh, what we can do now is we can measure if there is anywhere higher voltage higher voltage than what? Yeah, it's folded twice, like really, it was like folded. Look at that. It is folded like that. So this is how it looked like, and this is how it unfolds. And I removed it because we can fold it even further. If we want a closed device without this showing, I can fold it in and then basically make it very compact. But now I want to fold it too much because I don't want it to break. All right, so let's measure if we find any voltage that's higher than what we let's check those pins. That's 0. Where could be a voltage? Like here, what is this? 0, 0. What is this? What is this voltage here? Oh, we have some test points. Maybe we should use the test points. 1.4. I mean, if it was working with higher voltages, then also the no, you know what? If it was 3.3 volts or whatever, or 5 volts, then we would see it also on the pull-ups and the pull-downs. Ground, yeah. Okay, so one thing that I didn't mention so far, I wanted to use like the headphone and microphone jacks to tap the audio, but the problem is you have to plug it in to enable it, so you have to have something inside. So I thought, okay, yeah, let me just take one. We can take one like that, plug it in and interface it then. So the speaker would turn off. The speaker would turn off and we can tap the microphone or the audio output. But it adds like another centimeter to the size and I wouldn't like to accept it. That's why I took it apart and now we tapped everything. By the way, this wasn't the voltage. You saw that? That wasn't the voltage like from the battery, even though it told plus minus. That was a connection to the electret microphone. So actually, it could be that it's powered like because the electret microphone has like a transistor in series on the high side or low side. So probably we don't even want like to use one of those pins and just put the DAC to the other one. Or I really need to check again because my electret microphone video is ages ago. I think it's an electret capsule. Let me check the... Oh yeah, interesting. It has a pull-up resistor and then you have a capacitor. I to S, it's not I to S. Oh, maybe there is an I to S. If we can trace the traces, but it's going, I mean, it's all controlled by this IC here. So probably it's somewhere attached to that. And yeah, here's some logic or transistors and caps. Looks like tantalum capacitors. Better not short that or reverse or whatever. That would be a firework. Probably irreversible damage to the flex PCB. All right, did it disengage? Yes, it's disengaged. So I can even remove now the tape. So tape, there is one pin that we can interface if we print something. Hey, below this, that's an micro cassette recorder, and we are interfacing it right now. As you can see, there is like a micro cassette, and now I need to find a good place to interface it without destroying it though, because the flat flags might be vulnerable to damage. I would also like to... Oh, that's diet sugar-free Coke mix. It's a random, not Coca-Cola company related drink. Yeah, I'm wondering if I short stuff. Maybe I should use some Kapton tape to not short stuff here. We'll be able to see through while still remaining the function, retaining the functionality, preserving. Here we go. Yeah, it was folded, but it was like folded by pros, not by me. So, and I added some wires, so better not. Look at that, nice. Some Kapton tape. Here we go, Kapton tape to the rescue. Here we go, Kapton tape, and this is microphone. And this is the interface. Ah! Here we go. We could also, in future, we can power it from one of our PCBs here to be able to control it. But now I can show you. I know we decoded it last time. Here. Now it's oh wait. It's playing back. Stop. Stop. Record is this one here. Uh-oh. Oh. Power not good enough. Yeah, but it's power is dropping. Something's off. Oh, it's blinking. Damn it. Okay, let me turn it off and on. It's like something, maybe something's shorting here, but it's blinking. It has an error right now. Uh-oh. Need to be careful not to, like, there might be things touching. I will check the regulator. Yeah, but I turn it on again. It browns out. Looks like brown out to me. Strange. There's something touching here that shouldn't touch. Or is this too wonky here? Maybe the voltage changed and now we destroyed it. Hey, Eddie. That's a BLDC. Oh. Wait. Turn it on. 1.3. Okay, now it's good again. But the voltage was dropping. I probably need a capacitor to basically for the high resistance. Okay, let me try to record. Okay, it's recording right now. Okay, let me stop it. Okay, it stopped. Yeah. Wondering if it's this one here should be able to handle like 200 or 400 milliamp. Yeah. The goal for today would be to interface it and test what frequency range we can record and restore, like reading back what quality loss there is and what kind of encoding we can do. I already vibe coded a compression, not compression and encoding, but what was it? Gemini didn't like QAM encoding because the tape is like not consistent enough or frequency. That's what some people told me last time. Scope to test frequency range. Oh yes, we could test that, or we could test that here, but I would rather want to use the microcontroller to basically record the frequency like test thing and then get it back, like read it back with the ADC and see what we get, because that's like the most the actual hardware that we'll use at the end. And we can see if it's good enough or not, or we can improve later. Just have a nice video. Yeah, the noise is quite high. I don't know if it was because of the amplifier. Yes, we have FFT for the... But then, how do you measure that? Like, what is the frequency range? Would you just use a square wave and then see what frequencies you get? You can't use noise because there's some noise introduced, and then you would have like false high frequency response. So what would be the way of testing that? I want to interface with the IC, so let's check if we can get anything going on here. Let me check if this IC might be the right one. What is this? 208 now. Yes, almost. We are almost there yet. Yes. Most probably. Where's my... CH35XO30 reference manual. Here we go. Okay, what pins do we have here? Oh wait, I need the data sheet as well. Okay, here we go. So, what it says, we have 12-bit DAC. We have 20 kilobytes of SRAM might be not good enough. How much do we have? How much SRAM do we have here? It's not the data sheet, but does it say? Oh, it has, no, that's the F, V203. Oh wait, it only has, that one has a lot of SRAM. I think we will use 208 because it has like 64 kilobytes of SRAM. Yeah. Damn it. Do I have a PCB that has that IC on there? But it's similar build to this one. No, not this one. Is it this one? Huh? Wait a second. We, you know what? We can even reuse this programmer, but I really don't want to destroy this one. This is interesting. So, I mean, I used that for my other device. What is the size of the PCB? The PCB size even matches. I have more of this. I could just assemble it. Only the parts that I actually need, because I don't need like the connector and so on. This is strange. And we have even like for a potential DAC parallel or whatever. Strange. We could use that. Where's the other? Oh wait, here. Yeah. You have space to attach a wire, voltage reg. Yeah. I have more of those PCBs. I think I have at least one more that we could assemble. But is this the right one? So let's say boot, ground. So I would start with 2 or 3. Yeah, I will start with this one because I don't want to do assembly on this string. I just want to quickly interface and test stuff. So we will connect stuff here. I wanted to use MOSFETs to basically switch them on and off. Let me check that. Do I have FETs here? NPN. Oh, I don't have as many, damn it. That's NPN. There should be more. Or I will use a level shifter, but wondering if that is. can also just use these here for switching. Like, yeah, I dropped my box again of the transistors. Oh damn. Let's just use random transistors here. I would love to use NPN, but why don't I have more of these here? Yeah, mixed silicon. Yeah. I like the yeah, I don't like transistors. I really want like MOSFETs because I don't like current. No. I have some level shifters though. How about level shifting? High and low. Here. High and low. We can try level shifting because... Oh wait, what is this? Here. I have them soldered even. Level shifting. So this is low voltage. Oh. There is not enough space. Let me move that over here. We'll start again. Does it start? Oh, no. Now it will start again. Okay, so that's a level shifter. Never made that working. I don't know if that works. Okay, so we have low. This is low voltage. Ground first, okay? Ground first. This is ground, this is low voltage. How does it work with tri-state here? Maybe I should also switch to 3.3 volts here. This ground as well connected. Oh, doesn't work with 3.3 volts. Okay, interesting. Where's my 5 volts? Wait, I want 3.3 volts here. Let me remove that. Let's not use that part. Instead, we will use the power from the microcontroller. But we can use 5 volts to not overload the 3.3 volt regulator. So that will work. But we need some stuff here. Still a long one. Okay. Oh, where's 5 volts? V bad. Is there even somewhere? Is there 5 volts anywhere? Hey, Punish the Rookie. V-bus. I don't see V-bus here. It only say V-bad for battery. Can measure that though. Let's see what we got there. No, V bad is nothing. It's only 3.3 volt, that's strange. Oh, Eddie, thank you very much. It's just endurance, not skill. You know what? I just don't. I just plug in 3.3 volts, and now we have to like check if what we get from the LDO. LDO doesn't budge. What? What? LDO doesn't want to work with. Why? I think the outer pins are usually the power ground. Okay, maybe you see more than I do. Here we go. Do you see that? There is like 3.3 ground. LED, V bad is nothing, ground, and all pins, I don't see it. Crazy. Hey Z80, thank you. There is nothing there. Okay, maybe I need to. Okay, we're switching the MCU to this one here. This one seems to be better. It has V-bus. And it also supports 5 volts. So, okay, V-bus and ground. Okay. So I guess we are taking a smaller board then, or a smaller IC. I mean, we can always switch to the other board later, to the other, once I got some nice... I have another board that I could use, but it's from the LED matrix, where I have also everything routed out that we could interface. But I think I will just quickly test here, and then $500, what? Oh yeah, it can do power delivery actually. So we can give it anything. But more than 1 amp wouldn't be necessary. Okay, so I want to interface here. We have ground, now we have high voltage would be, this looks like this one looks broken. Let me take another wire. This would be high voltage is 3.3 volts in our case. What is it? High voltage. I never successfully used level shifters, so not sure what to expect there. I mean, we can, but we can try to, what is it, ground. Wait. Okay, here we go. That's stop, and that's, was it play or rewind? Let me check. Record, play, forward, rewind. Wait, what? LV3. Oh no, we can't use that. The level shifter doesn't support tri-state. Okay, so we need to think of something else. Let me stop the device. It's playing back right now, so let me stop it. Pull-ups on the high side. I need pull downs. Wait, yeah. but pull-ups to 1.5 volts. Okay, let me use the two transistors that I got, so we will be able to try if our two N. Oh, yeah, I shouldn't pull it off the circuit. But what would happen? I don't want it to be basically pulling up stronger than before. Let me just try the NPN transistor thing, not NPN, and N-channel MOSFET. So the legs of 2N7000A, what's the legs there? And where's the other one? I had two. Wait, I have a scrap bin with components that I used before, and it should be full of those. Let me check. Here, you probably from breadboarding, you know it. Like you have pulled off the components and didn't bother to sort them back. What is this? WS78. Oh, that's a 9-volt regulator. Yeah, I want to let it float. I want really like not very intrusive circuit here. So let me do it like, oh, there's another 35. I bought quite a few of those boards. What is it? 2N7000? 2N7000. No, wait. And MOSFET. Damn it. 2N. Yeah, 2N7000A, but that's not the part that I like. Fat. Ah, yeah, here we go. 2N7000A is basically like the power thingy. Okay, here we go. Here we go. So we need, first of all, what is this? What did I want to do? Oh yeah, I wanted to measure that because I can't read. Damn it, it doesn't work. Look at that. This doesn't work anymore. Not enough color pixels. Damn it, I just want to take 10K here. Okay, I take this resistor. One. Okay, here. What is this one? Could you tell? Yeah, my meter is broken, the ohm meter. I don't know where my other ones are. Carbon colors. Okay, you know what? Could even be an inductor. Okay, let's take a new one then. Here we go. 4.7K. These are 4.7K ohm resistors. Here we go. 4.7. We pull it down. I hate breadboarding. I rather design a PCB and wait a week. This is terrible. This is a terrible experience. Okay. Okay. Then this will be the gate, and this will be source. Source is here. No, wait, this is source. This is we need to connect. Let me get my cheat sheet. We made. Okay, we need to connect gate source. Source is here. Source is that. And then drain. No, wait. Source, it's pulled up. No, we do it like that. It's pulled down. So source, and we pull it down, which will be, no, we pull it up. So this is drain. And then what happens is, if I I need the second one so we can test it with play and stop. Much more exciting. Oh wow. Where's the second N-channel MOSFET that we found before? We need like at least a play and stop. Stop hammer time. It should be somewhere here. My socks, yeah, it's embedded in my foot already. Crash and reset. Alright. Level system, mini regulator. Wait, where is the mini shelf with the part? so much. Oh! Ah! It just dropped. It was on my sock. Here we go. Yeah, here we go. Here we go. We need another of those thick ones. It's chaotic here. I should clean up a little bit. I just brought the resistors. Where are they now? Huh? Excavator operator. Yeah. Do it. Don't let your dreams be dreams. I will write your name on the boom of the excavator. Oh, here they are. They just hid from me. Why do people forget there exist these? Do you know that GeoFacts? Was it GeoFact channel? That dude is so funny. Why do people forget that there is island of ascension? Population, I don't know. I don't give a good impression. Was it GeoFacts? Let me check. GeoInfo here.
Why do people forget that there is island with no snakes or dangerous spiders? This is Tahiti. It is island controlled by France. There lives almost 200,000 people.
There lives almost two. Oh, Johnny, thank you very much for Excavator fund. Now I need to translate the 100. What is 100? SAK to Swedish Corona. Okay, we have. Whoa, that's almost €9. I need to add this to my fact sheet. It's all. Everything is maintained. There is like Excavator fund. And there is 987 by Johnny with Johnny. Now we are a total of €75. That's 1.5% of the total amount. I will buy it no matter what. There's for €9. I'm excited for like that again. No, there is one thing that I will be more excited than for those €9. And that is basically. Look at that. Look at that. Look at the face here. That's me. That's me. That's the excavator. Don't ignore that part because there is some super chat. So we are 75%. I maintained the list. There is an actual list. Here. Ah. There. That's Here, this is the total donations. Also like Fu and people who put super chat in the excavator fund, everything is maintained. It's me. Yeah, yeah, it will be a mess, but it comes with all sorts of attachments, so Brian, this will help. How do I translate that? Thank you very much. That's like three bucks. Okay, I will put Brian. Brian. I just in the beginning of the stream I sent you greetings. You missed that. You have a quite good weather right now, like 30 degrees or 28 degrees. Here we go. 3 euros. It's probably like prime. What's bring it to I. That would be so. Oh, what? 10 RON? What is Romanian? No, what is interior crocodile excavator? What is RON? Romanian? No, what is wagon loads? Oh, that's sick. Now I need to maintain it. Oh yeah, here we go. That's 10. That's 1.97. That's €1.97 was donated by Pilotis. Thank you very much. Lou. Okay. So we have now 80 euros and 40 cents in the excavator fund. Oh man. I could borrow you my grandfather's skidster. What is a skidster? Oh yeah. But the skidster is like this part. Yeah, I need something to be able to excavate. Not only like push around. Okay, I mean you can push around gravel with that, or is it like a brand name and then actually it's like an actual excavator? Oh, I think GoFundMe is better than YouTube. But I swallow the fees. GoFundMe is a little fee, only like a few percent. YouTube is like 30%. So probably it's more like 70 bucks in total, not 80 bucks because of the. So but I take anything and just swallow the cost of the donations. I will swallow anyways the remaining missing 98%. Full thing. Oh, nice. Like for job site. Oh wow, like a proper one with a cabin, like this one here. Nice. Yeah, these are a little bit more expensive. This is not the actual cost. The Shepard ones, they cost like 4.8 without any. Oh yeah, put it on Discord. Nice. Yeah, Henrik, thank you. Excavators. Henrik. I need to. Okay, here another 2 euros. Thank you very much, Henrik. Caroline is giving about why you need one, but at the same time, it's asking you to come over. Yeah. I'm not sure if we can come over. Maybe we need to invite you. If we manage to have a good heating system in the winter, then you can come and visit us Christmas again if you like, because Tony is starting like a new job in September, so probably she won't be able to take any time off for a few months. Oh, she only wants you excavate. Okay, we can. Then I will just ship the excavator as soon as I have it. You can borrow it though. Or you visit us and she can play around with that here. What do you want to? Do you want to dig out a bunker in your? Oh, we can. Oh, Brian, we can excavate some turf. we can excavate some turf and take the turf. Okay, Brian, new plan. I take the excavator over to you. We excavate some turf and I take the turf back to here, so we will be able to heat the home during the winter and then you can come and visit us. It will be a full-fledged turf experience, like in Turf Lodge. Okay, let's excavate this project. I saw that. Yeah. Sounds like a good plan. Yeah. Oh, all right. I need to pitch it to Tony. I don't know if she is so convinced. Also, I tried to convince Tony to basically give it to me as a birthday present, but she didn't like that idea. It's a little bit too much. Excavators are cooler, yeah. Alright, here. Let's do play and stop. Oh! No, another one? What? Is this a follow? Yeah, just followed. OMP, hello. Thanks for the follow. Okay, I think this is play. And what we need is also to pull it high with that. Compost. Yes, I have a lot of compost and actually it heats up really, really hot. I had like a huge bag of compost and also like a barrel of compost, which was maybe half a cubic meter, and it got so hot it was like smoking. So it's quite dangerous, or at least it was steaming. So it is like more than 100 degrees C inside. It was really steaming. So compost can get and kill itself even, like the bacteria can kill themselves. Meat on. Okay, here we go. We have. Oh, you didn't see the action here. We have some action here. We have two N channel N channel N MOSFET N channel MOSFETs. Here we go. And I guess this should be stop. And this should be play or something. So let's play. Can we record? Okay, so this is, we have the N-channel MOSFETs and I try to play. No, nothing. Didn't work. VCC, no. Doesn't work. Doesn't budge. Is this the right one? My N-channel MOSFET thingy didn't work. Damn it. What could be the issue? Do you see anything wrong with this circuit? Oh! Wait, I was doing it wrong. Here we go. Okay, here we go. Here we go. This is stop, this is play. No. Didn't work. What? Oh, bye bye, Roman. Okay, let's check again. Sanity check. We have those two. Okay, let's try. This is stop. Wait, let's try. Sanity check. Huh? Oh, this is rewind. Oh, do you think the ground levels are off? No, the ground should be the same. Oh, wait. And also this is not play, this is rewind. Okay, so let's do that. Okay, so this was my idea. And what happens here, this is more or less they are floating or pulled down really like, I don't know, low. What I try to do is basically, well, what we can try to do is also, let me pull it up to 1.5 volts. Will this work? Okay, that works. Okay, so we can actually, damn it, I'm still recording the trash. What we can do is, what works now is just let me put the VCC power here, and I will try to do it here. Doesn't work. Do I need a P-channel MOSFET here? For that, only N-channel here. Yeah, let me check if I can find a P-channel MOSFET. I thought it would be working with oh, damn it. I don't have one like that, only SOT. What works is, okay, so this is, I will tell you here, so 3.3 volts. This is basically that, but what also I just tested that works is there won't be pink LEDs on this stream. Sorry about that. What? I need 1.5. There is none, okay. Disappointing, yeah, sorry. Yes, I can do that, I will do this. But not ASP, I will use the charm high. Charm high, no. That's the interface to the buttons of the player. This is what I found out. There is like a ground 5K pull up, something like that. That's 1 million or 1.5 volts, 1 million ohm, but we can roundabout. I'm not sure about that. Stop, play, rewind. They're pulled down, and there's 1 million ish pull ups. So there are. These are basically. Maybe I can pull. They're pulled down. That's. Maybe I should rotate that. Pull down. Pull up. So if we pull them up with 1.5 volts, that should be right, but it doesn't work. So it doesn't work like that. So probably I need a PNP, no, not PNP, and P channel instead an N channel MOSFET. Let me check what else do I find here in my scrap bin. But I think I never worked with, what is BC 547? 547, what is 547? NPN, okay. That's a 9 volt regulator. 3906. PNP. How do I do it with PNP and yeah, basically PNP. Because N channel, P channel MOSFETs, I don't know, I have some. Maybe somewhere. Five, 4, 7. Okay, I have an idea. How about we do it with passives? I need just divide it here. Let me pull that off. Yeah, this ground is alright. F this. Thankfully we didn't do anything here. Alright, so I will just do voltage divider Okay, so what I will do, I will just tap in the center. We can use 10K, whatever K, whatever K. So this is tap in the center and put this one here. That will be 1.6 volts, which is all right, I guess. Where's the second one? And the second one will be here. What? Poland is still there? Yes! Polska! Tuf, tuf, tuf. Polska! Tuf, tuf, tuf. I'm missing the best part here. By the way, yeah, I'm Germany right now, but I'm born in Poland, so I have an excuse always to switch when there's like a football match between Germany and Poland. I can pick the winner side. I'm a traitor. Last game, they already ruled out. Oh no! Kaspar! 8-bit boy. I know some basic logic gates, electronics, really want to do some project as a hobby and learn about this stuff. Like properly, where do you recommend me to start and make solid base and grow on it? Basically, solid base would be Arduino projects from YouTube. And then start like to, whenever you touch a new topic, let it explain to you by ChatGPT and watch the videos on that on YouTube. That's how I learned, but I'm not a good example. Hey, Yuyo. Or is it Jujo? I don't know. Okay, let's start. Now let's try to play. This is play button. Yes! It works! Is it playing? Yes, it's playing. It's playing. Okay. I can press twice. Playing different direction. Yes. Rewind. And now we can stop. Yeah, good sign. A good sign. Look at that. Okay, here we go. Let's look. Let's look at that part and let's play. Let's press play. Here you can see maybe the display. Let's play. It's engaged and you can see there. Is it so slow? Yeah, it's slow. And then we can stop it. If we do twice, it reverts. It reverts different direction because it supports like the lever, you can see the lever will switch. What? Tennis? Nice. All right, that works. All right, now we need an ADC. Is it still playing? It's still playing. Let's stop it. Stop it already. Okay. Now we need Linky. We need a Linky now. Oh, we need a Linky. Now. La 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 la. La 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 la. Linky, I don't know if that one works. I destroyed a few Linkies in the process, so that might not work, but anyway, well, let's try. Let's try. Okay, this is clock. We don't need that. We don't need that. We don't need the reset as well. Oh, reset might be useful. Okay, I keep reset. We need the data sheet. We need the data sheet. This is power, VCC. VCC. Oh, we don't need power though. Yeah, we only need, we have power from USB. So this will be reset then. Reset. And let's check. Where is my cable, extension cable for the... Yeah. Ah! Yeah. Ah. I might have rolled over this. Okay, so let's check the data sheet. We can't fix bitluni, or we can fix. We can fix that. I'm unfixable. I'm 46 now. There's no way back. I was a jerk, like in my 20s. At least some girls called me an asshole at that time. But I made like, I don't know. Oh, everybody was. I just didn't have. I didn't during my youth, like in the teens. I didn't have any success with girls whatsoever, and then I think in the 20s, I don't know, I was like less polite maybe, and then had more success with the girls, so was either that or that, so I don't know. But now, I mean, Tony and I, we are now 9 years together. I don't need to be long term. Yeah, well, 9 years is the longest now. And that's why I don't need to be a jerk anymore. Also, yeah. We are cured in this, at least I feel like in the 40s I'm cured from thinking I'm special. It's probably when you're a kid, you think you're invincible, you think you can be everything, you can become Superman or whatever. The revelation comes in the 30s. All right. Where was we? Oh, sorry about that. Yeah, my parents broke up as well, but The first knee pains. Yeah, oh yeah, I had already a knee surgery, but I mean, I did a lot of like sports that were not good for the knees, like gymnastics and rock climbing was not so bad for the knees, but bad for overall health because I had a little accident where I had to stop climbing. And also my knees, I did trampoline for quite some years and that wasn't good for the knees. Like gymnastics and trampoline wasn't good. That's like the impact is too violent for the knees. Master Muffle, never felt special, always useless. Ah, come on, there is something that you feel special about, like being the best at one game or whatever. There has to be something. Hello, Neo Brain. Thank you very much. Being the best at being the worst. Yeah, you know what? Where's my... I had like... my theme was the best maker in... The best maker in the village. And our village is like 260 people. And now... now I met somebody who has like some patents and whatever in electronics. So I'm not the best maker in the village anymore. I'm the second best maker. Even that, I can't even have that. I'm not sure anymore if I'm even the best maker in the street here. Man, recently my solder was kept on 4 time at the max. Some solder onto it. Oh shoot! Eddie, is your eye okay? Paradox found. What? Wait, paradox? Oh yeah, I'm streaming on Twitch and YouTube at the same time. So if you're looking, it's the chat on the screen is mixed here. It's mixed YouTube and Twitch. Nah, man, it's not good. What? Oh no, it can heal. Twitch, yeah, it can heal. My eye was gross. DEFCON? No, I'm not going to US this year. Sorry, it's too expensive to travel there and too unsafe. I might have said a few things about the president. I don't want to like be sent back at the border. Eyeballs, I can tell you. Wow! Sorry, that's wrong. I can show you. Deported, yeah, I get deported. I don't want to be like detained and go to JD Vance. I have only, my phone will be confiscated because I have like some photos for sofas and couches. Here we go. Oh yeah, here is my TikTok. Here is my TikTok of my gross eye. Here. So gross. This is what, that was my eye injury recently. And it healed. Gross! What? Tripped is... Oh yeah, it was stick in my eye. So you probably use soda thing, as long as it wasn't was it lead free? Why isn't it the description? Which one? Which description? Oh, isn't it? I don't know. We can add it. Let me check. Oh, wait. YouTube, like on the videos or like on the channel, or go to where is the details? Here we go. Let me check. By the way, video's going really well. Can't complain. 660,000 views in 1 week is amazing. No, Twitch is there on the videos. You can see that here. Twitch is here. Scroll down. Scroll down past my advertisers. Then all the affiliate links. Then some more sellout stuff like support stuff. You get Mastodon, Twitch, Live. There's even the Discord and Blue Sky. I'm also on Blue Sky, so you can. Twitter. I should remove Twitter though, but there are still people on Twitter. I don't know. I don't like Twitter anymore. Oh, it's not on the stream. Yeah, because you're watching it on YouTube, so probably it's your favorite thing. I don't know. I could put it there. I'm too lazy. Let's continue with our stuff here. Didn't we want to code a little bit? So how do we start with what do we start with this device here? GoFundMe. Thank you, Dutch. The Excavator Fund. But if you read the description on the Excavator Fund, you probably don't want to donate anymore because I discourage everyone who lands there. Eddie. Infrared following camera. So you want but you don't want to implement kamikaze drones or rockets or whatever. Rocket guidance systems. And demonetized. You can use like the really cheap USB thermal cameras. They support basic like video outputs. You can even like use them with the PC. I showed it before on streams. So you could use. You can use in the Raspberry Pi and then I don't know, track hotspot on there, like bright color means hot. Or do you like to take like the small IR thingies that have like 4x4 IR guided missile project I'm trying to make? No, I don't want to be involved, Eddie. But Raspberry Pi would work. Hey, Pilot is what? First time chat? Huh? Oh, you're in both now. I'm confused because I saw that name just recently. Okay, let's code. We're chatting too much, peeps. We don't do any work here. It's already 10 o'clock. We had 2 hours. Oh, where are we? Encoder, packet, decoder. Oh yeah. I have a new vibe coding implementation. People sign off right now. Okay, so friends showed me RuCode, which you can basically let it code like complete project, including design and so on. RC? Yeah, it's legal. I mean, if you take like the IR cameras, I mean, let's take a break. IR cam, was it 16 by 16 or something? Here, infrared array. Here we go. This is good enough for guidance. So I would take that, and then you can just basically measure the magnitude on the left side of the image, on the right side, up, down, and then you can guide the servo. So whatever you're trying, if you're doing like I don't know, propelled system like an airplane, and then you have like some wings or whatever, you can basically, the steering amount of the servo I would attach that to basically the balance between the magnitude of this side and this side, and to the other, like left right would be this side and this side. And there are modules with that thermal module. There are modules that have that already. No, where is it? AMG 888. Let me check that. Oh, like low. What is this? What is this? Copy aim 250 meter distance. Oh, so you probably, yeah, you need a higher resolution IR camera then. I don't know. And then tracking hotspots. Oh, look at that. What is infrared sensor? What is? No, that's the small one. Camera. We need to see what we get. Oh no, you want the thermal camera because the focal length, yeah, you need probably, but this is hard to get like a really, you either need a higher resolution and track the inner pixels, or you need like a lens, a specific lens. Look at that! Oh, that's $70. It's a quite expensive project that you're in. Yeah, 24 by 32. You can get 450, you can get a decent resolution camera. I wasn't able. Oh yeah, AliExpress. Please stop talking about rockets. Demonetizing here. IMG 888. Okay, let's. Are you sure about that? Streaming on Saturday. Foo! Welcome to the stream. You missed the fun. No. That's not what we're. Here, 8833. That's what you're looking for. Now, but this is also low resolution. That's AMG 8833. It's also low resolution. Oh, what is this? No, 8x8. Huh? But this is a higher resolution what they are showing on the screen than 8x8. It's misleading display here. What is this? This is never. Yeah, look at that. This is never the resolution that you get. Unless you stitch it. Because you get like, the resolution is like really low. Yeah, so Infi-ray. Yeah, that's fake. This is real. Like $250. And you can get different lenses, so a different, but these aren't fake, and yeah, they're quite high resolution, and you can basically, you bought a lens. Oh, 1 2 3 4 5. Hello. Yeah, Raspberry or microcontroller with USB host, full speed microcontroller with full speed USB host. But in that case, some Linux thing would be good enough. Do you think Germany will ever recover from automotive crisis? I think about being laid off second time this year. And oh, what? You're in Germany? Pilotis, I guess that Germany might recover because now there's like electric cars are basically deductibles now, or companies, if they buy, basically that's like a good way for the companies to like sell electric cars in Germany now. There's like new laws, but VW needs really to speed up, but not Bosch, probably not. Like Continental and Bosch, they're probably in trouble because there's too much of like the combustion engine suppliers stuff going on there. Yeah, I don't know. Maybe BMW is quite alright, I guess. Audi, maybe. It's hard to say. Hard to tell. Oh yeah, automotive. Yeah, you better go to BYD. Then sorry. All right. Anyways, let's continue. I want a different. Wait, how do I do a new project? This is something that was vibe coded by Gemini. It implemented like encoding and decoding with ADC stuff and so on. Wait, which wait, let me test which MCU that is main. Which MCU did it use? Is there like the only openings in China? Yeah. Go to Shenzhen or Shanghai, or I don't know. Try that. Oh yeah, but VW just closed one factory in China. I think like the Chinese have a better place like transistors. We are chatting a lot today. Okay, I want to code something. Wait, how do I start? Let's go platform IO. This is the wrong project. Foo! Is this for the excavator fund? 10,000? Let's go. Foo. 10,000. Whoa! That's like €2.10. Foo, you're added to the excavator fund. Thank you very much. $2, yeah. It's a little bit more than 2. Thank you very much. And what does the tape store in analog or digital? Only analog. That's why we need to encode. Skidiki bi pop pop. Skidiki pop pop. Yeah, it stores only analog. It's just a voice recorder. So this is basically, sorry if you missed that part. This is a voice recorder, and we can. This is like it's playing. There are like two play and record heads on that. We can also do second side, and we can stop it. So I just disassembled a tiny voice recorder, and these are the tapes. Where's the tape? I can show you. This would be a digital tape. There are smaller ones from video cameras, but we are only using analog here. Audio. Where is here? These here. Can also open it. Bloop. Probably, I don't know. That's what we want to find out in the next streams, my friends. I just want to interface now. Only organic, ethically sourced cassettes, magnetic tape bootloader. This will be amazing. Mwah! And the possibilities. This, I mean, I thought that the M.2 LED matrix project would take off. It didn't, like 170k views. But the cluster thingy here, this one, it exists. It's not a rendering. It really exists and it works. It doesn't focus. Focus. Here we go. Yeah, with all the bodges, the tiny wires here. It's existing. What is it? 700,000 views almost? Yes! Ah, 670,000 views. And it only got me. You know how you only 1.2k dollars. That's like 1,000 euros for three months of work. Thank you, YouTube, for nothing. That's why I need to put in ads. So, peeps, you understand why I need to sell out on ads. But I think the sponsor is quite happy. They had in the contract for like 200,000 views, and now it's at 600. So probably Incogni is quite happy. You want to see Incogni, by the way, because a friend of mine asked me, yeah, does it work? We can check. I hope I don't dox myself, but here we go. Let's see what they did. Oh yeah, here we go. So I just joined before when recording the video, so it's only quite fresh. Here, let me check that. That's the sponsor. So June 30th I joined at that, and I have suppression list entries, full activity log, detail view. So this is how it looks like. So suppressed, like high severity, they have like report on a suppression list for the data broker. This is how it looks like basically. So I actually tested and it was quite quick, like adding a lot of the suppression lists and removing me from whatever data collectors. But it's not like 300 right now. It's 48 cents right now, probably because of Germany. And it's completed those requests, and you can do custom removals. So, Deshipo, what is your page? Court records, okay. Okay, Deshipo, what is your page name? This is incognito. Deshipo art. I will Deshipo. The Shibu art, I will remove all my data from your site. This is how you can do that. But this is like, I think this is only premium subscription. SHA-256, yeah, it does. Actually, yeah. I forgot everything about that, and I had this even in my school. So I learned that, like code, error correction and stuff like that. I learned that in university and even in school, and I forgot everything about it. There are probably... Oh wait, channel codes. We might even have tone generation. There might be even like... Oh, it's Manchester encoding. Okay, so this is what Gemini decided to do, like frequency, but it's only like very simple. You have like two frequencies, which is 0 and 1, and it has like encoder, and it does even a CRC8 Manchester encoding. Blah blah blah, Mr. Freeman. And I don't know if it works. I only compiled it and fixed like two issues, integer like signed unsigned mismatch, and there was like a function used that was just declared underneath, so I need to like, but it did, yeah, it switched to the Arduino API for that MCU. Telephone like modem, yes, basically it will be telephone modem, but I would like to explore more. So my goal would be, I mean, maybe we write it down. I like to write stuff down. Where's this here? Oh, wait, let me check so I don't dox myself. Look at this. This is how my work after releasing a video works. After the first like 2 days, I measure how many clicks a video gains for an hour. So basically that was like the initial title. It had like 1,361 views in 1 hour. And then basically 1 hour later, I switched it to something else. And then it had like 10% more. And then I switched to, I made a GPU at home, which improved from 1077, then tried CryptoMiner, but that was at midday, so people in the I don't know, break, in the lunch break, watched the video probably, then changed it back, and so on and so on. So now I'm stuck at this because I tried again and again, and there was like, it looks like I made the GPU at home is the best title right now. I couldn't, even with Risk V, I had like Risk V, and it got worse. People, as you can never tell what the best title for a video is. I wonder what somebody could make a game that utilizes the whole 160 core Risk V supercluster. Yeah, so what you have been saying about SHA encoding, I didn't elaborate why it's so good at this particularly, because these MCUs, I could take different ones that support like multiplication and division, but SHA-256, it's only arithmetic operations. So basically, there is no opcode that, or no arithmetic operation that this MCU needs like to emulate in C or like have like a soft implementation. Yeah, we have A/B testing for thumbnails. That's what I'm using. That's why we landed on this current cover. But there is no A/B testing for titles, and that would be really nice. So actually, arithmetic operations or logic operations, shift operations are supported by this MCUs, and if I would run the code from SRAM, it would be able to run one opcode per cycle. Because the code is on flash, it runs like 2 cycles per opcode or something. So it's quite fast. It can do like 24 million arithmetic operations. That's why SHA-256 is so alrightish on those and low power. Interestingly, this MCU here, yeah, it's only like logic. These MCUs, like this one, this one here is only 2 cents more, has 100 megahertz, way more SRAM, supports like integer multiplication and division. So probably we might want to try that one. And then this one has even more GPIO. I don't know what. Put in the widescreen. No, in the small one. The widescreen. You want to see that? Here. This is the CH570. Yeah, this. That's the one. Okay, so there is the 570. It has like the radio but doesn't support Bluetooth, and there is the 572 which supports Bluetooth. It's the same chip. They just it's the same chip. They just didn't pay the license to Bluetooth, so you can't put Bluetooth on that, but it's probably totally fine running Bluetooth. So this chip is really fun. Let me I'm distracted all the time. There is no implementation. Okay, here is the there isn't even a separate data sheet for that chip. So 572. Let's check what the specs are. Overview. Here IMBC, so it can use integer multiplication. I don't know what's BSC is compressed. So there's a lot more going on there. We have 2.4 gigahertz RF transmitter. Here 256 kilobytes of RAM. What? 12 kilobytes of volatile data storage SRAM. That's alright. Like 12 kilobytes. Or okay. Yes, basically it's interestingly just as like the 035, it has an internal 5-volt regulator, so you can directly run it from USB without a voltage regulator. That's quite cool. So what I also thought, I totally didn't get that part, that the 035 is 5-volt tolerant, which means we can directly interface with C64. This one as well, but it doesn't have enough pins. I need a 5-volt tolerant MCU. I don't want this level shifting. Okay, yeah, so way more capable, and it has like 100 megahertz. What's the speed? Where does it say? Here, 100 megahertz, so it's twice as fast. It's not that much, yeah, I know. But they seem to fit a Bluetooth stack in that wireless communication. .4 gigahertz module. Look at it. 2 megabits per second. What? That sounds really cool. All right. All right, peeps. Wait, let me check. Wireless. Where is BLE protocol? Yeah, Bluetooth Low Energy 5.0 specification. Yeah, that's a lot of code, but the Bluetooth stack is quite huge. I remember, like, if you want to use if you want to use Bluetooth on the ESP32, you need to change like the app size, like the file system allocation or segmentation or whatever on the flash, because Bluetooth stack is so huge. Anyways, back to the chopper. Didn't we want to like ADC something? How do we start a new project here? General, open, default, general, upload, monitor. How do we start a new project in open? Open. Here we go. New project. New project, project name, CH32X3035 ADC. Oh, which one is it? Oh, F8, U8. Which one is it, peeps? Which one is it? Oh, this is this is our sketch. Good. Reference manual, data sheet, pinouts. Let me check. Oh, that's the R. G8U, I think this is the one. Or is it F8U8? Yeah. I think it's F8U8 that we have here. How many pins does it have? I can't tell. Damn it. Okay. Need to shine on that. Can't read. My eyes aren't good enough. Let's use the camera. I have like this periscope mode on my camera. G8U5? No, G. Or G8U6? Oh, might be U again. Ah, can't read. Too low. No, it's... I guess it's U6 then. Alright, G8. Huh. Where is it? Damn it. G8 U6, this one is it? Okay. No SDK or if the USB doesn't work. Oh, there's Arduino. Hey system, you're alive! I'm so happy to see you alive. Dude, that was crazy. What was going on there at your country? Thankfully, you're in the wilderness. Woof! You know what? I will test it with. Can we do Arduino? Free, no SDK. Yes, let's use no SDK. Use default location. No way, video. Oh no, that's the wrong thing. Damn it. Videos here. Oh, you have quite some delay, sister. Crazy, yeah. Damn it, is your family okay? At least it's over now. It was like, I mean, I must say, I don't appreciate Donald Trump and his politics, but at least he put an end to like this conflict, or I don't know, this war, by dropping some fart bombs on that mountain and telling Netanyahu to stop. 12 to 13 days, yeah. 12 seconds plus 144p. Oh wow. Everyone is fine here. Ah, woo! Fart. Yeah, I mean, this bunker buster bombs, I mean, they're just fart bombs. It just evaporates on the mountain. It's like, yeah, I know. That's terrible. That's terrible. But imagine if, like, I mean, like the sacrifice. What was the sacrifice? I mean, the U.S. dropped like the bunk busters on the research facilities in the mountain. You don't know, probably there's like they need just to excavate the tunnels or whatever. But yeah, I don't care. We can talk about that. So basically, just Donald Trump wants like to get Nobel Prize for peace, and that's why he was like sick of the BS from Netanyahu and basically made him stop. and that's good. That's the point that brought that conflict to an end, and it never should have started in the first place. It's always the same, I don't know, same things going on. It's full troll at all times. Yeah, politics. That's the only thing that I feel appreciate. Invade Norway. We had like former US presidents getting the Nobel Prize that probably didn't deserve. I mean, I think, you know, Obama got the Nobel Prize before he even like at the start, at the beginning of his yes. I mean, he got it like before. It was a promise. Yeah, that was strange. Probably they just wanted to put pressure on him. That's like gaslighting. So, I don't know. I can't like not so. I can't remember what happened during Obama's terms. It was two. Was it two? Yeah, it was 2 terms of Obama. So basically, the Nobel Committee put pressure, political pressure, on Obama. Yeah, we have hopes that you will keep the peace or whatever, regain peace with the world and try to unite, or I don't know, be an ambassador for peace. So that was a good manipulation tactics. Yeah, Bush was. Drone kills seem to have to ramp up. He got it by default. So who's getting the peace Nobel Prize? When's for being black? I mean, he had like his campaign was hope, and many people got the hope. Like, I don't know if you can also sell a thought. I think it was like some sort like putting pressure on Obama to basically bring peace. Peace forever. Yes. I think, yes, let's not. You know what? I think everyone should get some Arduinos and tinker around and enjoy themselves looking into old VCR recorders and hacking them, and everyone have like peace. Everyone can stay in their basements and tinker around and just not being a jerk to other people. Is that so hard? Just don't be a jerk. Yeah. Stay at home and take apart old CRT TV and try to make it an oscilloscope or whatever. This is my pitch. I want the Nobel Prize for peace right now. Make stuff, not war. Yeah, always like constructive. Be constructive. That's the only mantra that I support. No, I'm really happy. I'm really happy that you and your family are right. I know terrible things happened. It is what it is. And nobody expected this conflict to end that quickly, and we are happy about it. And we hope that peace will be kept for a long time. Lovecraft? No, not Warcraft. Yeah, Lovecraft. Let's make art, not war. System is from Iran, and it's really hard for System to join the stream. People's toys are different. Yeah, we have some narcissists out there. Anyways, let me find where to put my microtape, USB microtape tape, first tape ADC test. Finish. Yes, do it. Oh, that's 3. OMP. Just stay at home. Sound too close to the just stop complaining people. I mean also OMP, I mean also the people who make the war. They should be rather constructive. Stay at home and don't like try to attack others. Use it as a disk drive. The tape using... Yes, I trust. What is this? Huh? Why? Where is open? What is where? Open and edit on what? USB tape? What? Where is this? Is ADC? Okay, here. Okay, here we go. How do we add PIO? Is there an example project? No. Boards, platform, devices. Platform. Oh, damn it. Okay. I can have... Yeah. That question? Yeah. I try... It doesn't trust its own files. What do we... Wait. We can copy some ADC code from the SDK. Let me check. Oh yeah, I have like the SDK. So I have no clue. That's what we want to find out. We are distracted all the time today, so that's why I can't find out. But we can do like another hour and try to read the ADC and I don't know, maybe PWM something on the tape. It should be doable. Dataset with turbo tape. Yeah. 100 kilobytes per site. Oh wow, that's not a lot. Maybe we can do more than terabytes. But this is not a mod. This is just analog audio. And if you have listened to the audio that we recorded with this device, it was terrible. LED flash pattern written on a tape. Yes, basically something like that. GPI. I used how do we run it though? USB power delivery. I want to check if I can copy the code, the USB, the USART. Almost hi-fi. Super cluster programmer, because I used here. Okay. Source. Wait a second, that looks different. Peripheral source. Hey Arrow, we trying to interface this tape recorder with the microcontroller, and now I'm setting up the project and I totally forgot how that works. We had, wait, the cluster programmer worked with USB. Where is, like, I don't have the... Doesn't have a single file. Has it? Yeah, here we go. Okay. And you see it compiles some stuff. Executing. No main. Okay, here we go. But I would like to have the main CPP. ESP camera, yeah. Psh, don't spoil everything. Don't spoil everything. System. I want, okay, here is my spoiler. I want to put a digital copy of the video that shows what this device do on the tape itself. The quality will be terrible. How big is it? How big can a video be? Probably doesn't work that well. But no, there's so many cool projects that I can imagine. Where's my USB stuff? This is not the right project. ASCII art video, yes. CDC. Where is my... System fix. Oh yeah. Here we go. Source USB. Then we need a main. Oh no! How do I split that? I want to... The main should be in source, not in... here we go. USB, here we go. That's the main. Then there was the system fix. But I'm not sure about system fix. Test USB, readme, include. Okay, whatever. Okay, the main. There is no Ray Marcha. There is USB serial, serializer, main, internal to 48. What's the clock of... 300 bits, maybe 1 bit video, and then we have like, what is it, 18 by 16 pixels. Oh no! Oh, that's bits. Oh no, we have 7 by 8 and then 4 frames a second or something. And we need audio. Doesn't sound good. What is the highest clock speed? 48 built in. Okay, here we go. That's the. Oh, is it by default? Oh yeah, it's set by default. Nice. Okay, so we don't need that. We don't need the system fix. Okay, let's compile it. But what does it do? Wait, read. Okay. Serial, vector write, serial flush. What does it do? Load scene? Yeah, there is no load scene though. $69. No, we don't need. Okay, I will just compile that and see what problems we get, because this is code for a different chip. Oh yeah, here we go. USB serial. Where is the problems? Oh, you people, you will love it. Wait, what is this? Oh, there is a USB in the... Okay, I need to find... There is an implementation for USB. Let me check that. Include library, include... Where is... Packages, no, it's the peripheral. It's in the peripheral folder. USB H. Do we have like an example for CDC? Because I have like an example for file system. USB CDC. CDC. Oh. Yes. Aha. How about we just use analog? Shoot. But yeah, the problem is I have an implementation, but for another chip. I might have another version of that SDK. Maybe there's no stereo. I can use you don't spoil everything what we do. We can do whatever. Wait, CDC USB. No, there's only file system example. The head is, I think, mono. Not sure. We can check that. But I don't have access to stereo right now. I would need like to rebuild the whole hardware, and I was thinking about that. We can print a lot of stuff. I just need like the head, and we can just use this device just uses a lever to switch from A side to B side. If we use two heads at the same time, we could read A and B at the same time. So we have stereo like that, and don't bother about switching the sides. That is already one thing that we could do. There is no CDC, I believe. USART. Yeah, it has two heads. Damn it. Okay, let me check if I can read what we have. USB file system. USB class request code. Let me check if we can find anything else about CDC. There's no function. It's only headers. Yeah, we have like this implementation. I don't know how similar they are. Maybe we are wasting our time. We should just connect to the serial and be good. Because at the end I won't even use this CDC. Wait a second, I can also do the following. Charles Lore just sent me infos on his implementation. Let me check that. There is here. Upgrade to new version, make file. Here, that should be able to support. Let me check. the code, system USB setup. We can maybe switch the SDK and try that. RV testing. Bye bye. System, be well, stay healthy, take care. Okay, let me try to switch the SDK. Yeah, platform. What's the framework? How do you change? How do you change? Oh no, I didn't want to do that. No. Quick access. How do I change the SDK here? Configure. Here. Bye bye system. H32 fun. Oh, what's the how do I, damn it. Now it doesn't show me. Okay. Save. Let's see if that works. I will also remove that files because that wouldn't work anymore. Remove. I also remove that. And now, oh. Ah! Failed. There's no main. Huh? Erase that? L400? I don't know. I don't think so. I don't know. Why does it now try to compile? How does that work? Okay. You know what? CDC example description. Oh yeah, it doesn't work on Windows, the CDC Charles implementation. Phew, another 4,000. Thank you very much. It's for the Excavator fund. Where's my sheet? I need to maintain the information here. Thank you very much. Another dollar, yes. Excavator. Where's my sheet? Okay, I will find it here. Sheets. Excavator fund. That's 95 cents. Oh yeah, it's a dollar, but euros. I mean 95 euro. Ooh, another. Thank you very much. That is amazing. We are at 85 euros already. That's all right. I'm lost with this thing. Maybe I should just take an example. You know what? I will just take an ADC example. ADC DMA or what? What was the other? Because I had the board here and it had 5 volts, but I mean we can use any other board. We could use the programmer board as well. Maybe I should. Here. Do we have 5 volts? Yes, we have 5 volts access here. Okay, you know what? I have working, yeah, I will just, you know what, I will, yeah, you're right. We should have used the programmer board for the mini things in the first place. So let's switch it to this board and this is ground 5 volts. 5 volts. These are grounds. This is 5 volts. And we can just plug that in. We don't need this one, but okay. We need clock, and since I like to use, this is clock. No, wait, we need a longer female to female cable. Okay, whatever, I take this one. 3.3. We can do that. This is clock. SW clock. This is reset. And this is ground. I hope this device works. All right. Let me copy a project. Supercluster code. Complete classroom. Yeah. Web tool, PCB, web uploader, pub2, CDC renderer, CDC cluster ray marcher base. You know what? Cluster ray marcher. I will copy that. And to what is the USB type, or what was USB micro type? Test CPC. Okay. New window. Trust the authors. And we can close that. Yeah, whatever. Huh? Yeah, I don't care. Workspace. Okay. No SDK, sorry. Test source, USB USART, USB, I just need to find main. Ray marcher, we don't need that. Part. System fix, STD, timer, GPIO, hosts, define host programmer, if def. Yeah, that's what we want. Else USART serial. Okay, here get packet. That's, we don't need that. Main. We don't need bus. Host bus. USART, USB serial USART. What is this? Init USART? No, we have USB serial. Alright. Don't need USB serial, host bus, nope. No need debug, get packet, no need that. I might need to change a few things, but serial write, yeah, we have that. Just to know that that works. Serial flush. Flush. We have no bus. We don't need to do that. Serial begin and need that. Okay. Flush. Okay. What's the What's the matter? Okay. Let's upload it. The cheap yellow display. Oh, not really. It opens up too much. Too many possibilities. And I also don't have one. So NR. Huh. It might be the broken MCU, the broken linky. So let me switch the linky here. I know for sure that this one works. Oh wait, here it is. They connect the right one. Yeah, that must be the right one. I should mark this one as broken then. Yeah, that works. Okay, so this one is broken. I will just mark it. Probably just some issue there. Anyways, yeah. We need to chat OpenAI. Now we need here source file or test HTML. Okay, vibe coding. Okay, we need a controlling as following buttons. It says following buttons, which are stop, play, rewind, record, and direction. What? Simple now. Fast forward and rewind. 2 taps, fast forward, okay. sense oh, rev, thank you. Rewind. Button sends a byte. With for when pressed and displays the receiving data in a terminal that that's oh no, receiving data in a scope that scrolls from right to left, showing good night Deshipu, that shows values, the values between 0 and 255. How many values do we show? Yes, what's wrong with that? Shani, what's shows between, okay, it's good enough. This will be the test. We can maybe make it, wait, take int static t, yeah, whatever, count, and then, or I, whatever, I plus plus. Okay, that's the test. Upload that. Then we need we have, oh yeah, D. No, wait, this is, what did we do? Can maybe copy that from, no, I need to open KiCad, the new KiCad window. Remind me later. New KiCad version. Alright. Okay. We have some pins that we can maybe reuse. Otherwise, might be difficult. Okay, so. We can VCC and reset. Where is it? Okay, here, PB9 and PB15. PB9 and 15. All right, here we go. Stop will be 9. And play will be 15. Okay. Nine 15. Other than that, I would need like to disconnect this huge header. What else do I have? That's only grounded 5 volts. Hey, that's I mean, it's a platform that we can start testing. So this is GPIO B 9, 15 are both high. Equals 15, that will be 4, no, 3, 4, 4, 3, 4. This is wrong. 8, 9, 10 as output. That's wrong. That's not what it does. Okay. But that's all right. If serial available, oh yeah, if serial available for write, available, then read. It's still there, guys. Dudes and dudesks. Available, then Wint 8 serial read comment. Yeah, what is this comment? Switch. Let's see. Happy poop, yes. Oh, that's cool. That's all right. 9. That's basically 1, 9. Then we have delay, ms, 100. BCR. Okay, so this will be 1. This will be 2. 15. Okay, so we will be able to control it hopefully from unknown command, yeah, whatever, from that device. And what's still missing is ADC reads when we play. Okay, where is our vibe coding? Here, copy, should be good enough. Test HTML, boom. Can we reveal in File Explorer? It's easier than doing other stuff. Here we go. Connect. Oh, which one is it? Ray Marcher. It's not the Ray Marcher, but I connect. Ah! It works! It's too fast. It's too fast. Yeah. It reads the data and displays it. Okay, now let's now let's do the following. Let's see if it arrives, if data arrives. So let's write not plus plus. Let's set I. This is basically 0. Or let's do it like 50. And this is I 200. Okay, so let's try that. And I need to rename that descriptor here. Where is it? Serial CPP now. Do you see descriptor? Descriptor here. String serial. Okay, here we go. Descriptor is bitluni ray marcher tape drive Ah, meine Augen! Oh, we can even do a space in here and remove that one here. Okay. Wait. 0. Because it's white characters, my friends. Okay, let's do that again. So we can see if that arrives, because I don't see anything happening on the MCU, on the type drive though. Maybe we need to make it slower. Okay, so connect tape drive. Look at that! I love it. Okay, stop. Doesn't work. Play doesn't work. Forward, okay, that doesn't work. So writing. Now we need to find out why it's not writing stuff. Send byte, uint array write, read loop. Okay, draw scope. That is alright. Get reader, get writer. It should be writing. Send byte. Send byte. Ah. Okay, let's see if there is an error in the. It remembered that I like dark theme. That's, or is it by default dark themed? No, it's alright. Connect. Must be a problem in my code though. And we should also delay microseconds. Let's do only 10, okay? Should always be default. Oh, it's ASCII. My fault. My dudes and dudesks. Okay, here we go. X1. I will not use it. Okay, here we go. Tape drive. Here we go. Boom. Stop. Play. Okay, those work. But the tape drive doesn't react. It's too fast. Okay. So we can now delay micros write ++. We will have the jump anyways, and we will wait 1 second, okay? Here we go. 100 milliseconds is not fast enough and not slow enough. Okay, connect. Didn't work. Huh? Let me measure if we get where's the ground here? Okay, let me. This is play. Oh, GPIO. The scope is just showing a demo data, so we see that we get live. But there is something missing. There is missing enabling GPIO-B in the first place. Where is it? Yeah, I need to do that. Where is it? This is not the right project. how do you enable peripherals again? Damn it. Okay, here. Here I need that. Yeah. This was missing. Need to enable the peripheral before I can do anything with that. Okay. Connect. Hey, lass die Circles. Ah, I do it. Damn it, I do it the old way then. Come on. Let's do it then the old way. I might have an error here, so let's init structure sort GPIO pin 9 mode out P, that's pin 9 B. Okay, 15. Okay, let's try conventional way. Maybe I messed up with the pins. It received everything, I can see that, but I don't see it on. What the f... Is it right though? Need to... Neither this nor this does anything. And I don't see... I might missed something on the pins. Not that this is like... But no, it shouldn't be. In this... Peripheral B, push pull. See. Yeah, I need to check if I'm right here. Oops, sorry, this is the programmer. I think this is the right one. SWN VN VCCN GND SWN reset SWN reset N. This is here as so that's correct. They have even a pull up here. That might be not even great that this is like on pull up all the time. But push pull is should be pulling it down. Let me check the voltage on that. But it was showing 0 though. I'm confused. Wait, can I detach that and just let it blink as well with very slow, yeah, we should be able to set high clear scope dial. Hey Maisie. Oh, you know what? We can also do the following. We can just use that part. Basically switching from high to low like that. On the pin as well. So pin number B9. Am I right? Is it B9? Yeah, it's B9. B9 should be initialized. HR, that's 8, 9, 10, 11, 12, 13, 14, 15. Okay. We'll figure that out. Okay. Oh wait, I shouldn't increment. But I can just measure now. I will measure what this does. Okay, stop. Let's play. Play should be set high. Oh, that actually is high. Okay, that is high. Stop. Still high. Stop. High. Play. Nope. Oh, doesn't do anything. Or at least it doesn't change. Was it all from the beginning? Wait. Clear and set. What? Am I not educated enough to understand it? Yeah, they are here. That would be that one and these here. Should be initialized. I don't know what's going on. Okay. Okay, that's odd because I get, maybe I use this one here. You can see, okay, when I measure both pins, I get like 11 millivolts, so they're not active. Let's connect. Wait, tape drive here. Okay, so we are connected. Still low. Then I do play, high, high. Then I do stop, high, high. Huh? Stop doesn't work. Case 1. Huh? Yeah, that's... It should clear the bit. It's push-pull, clear it already. Hey, Whiteland. Should be clear. We can do the following. I equals basically CMD times 10, okay? And not increment that. So we see what we receive. Maybe there's something odd and we only receive... Oh, look at that. I removed the break. Ah, okay, yeah, I leave it anyways. Lol. Okay, so now check again. Yeah, master developer play. 3.3, 3.3. Stop. What is going? Oh, come on. I just used the device. Low. Low. Okay. So, what I can try now is... I should... Oh, wait! I connected the wrong thing. We never used play. Oh, no. Alright. Okay, so let's... Which was a reset and which was switch? Reset is... this one. Okay, so this is... that was my mistake. Yeah. Yeah, I should stick to excavators. Okay, here we go. We upload the code. Uh-oh. Yeah, it was pulled up. Uh-oh. It's playing. Can you even see that? device is playing, because yeah, we need to connect and disable it. Here, stop. Uh-oh. Now it's going in other direction. Stop doesn't work. Why doesn't stop work? We can switch the direction, but is it stop even? It must be stop. Let me measure it. Okay, it's sending the signal. What? No! Sweden won. But we are qualified anyways for the next round, aren't we? That's alright. That's a donation to the Swedes now. Okay, I will try to stop that. No. Maybe play is high all the time. Sweden. Maybe play is high all the time. No, it's not. Zero. What the F? I want to stop. Something's not working well here. Doesn't react at all. I don't know, let's restart the device. Okay. Okay, let's start again. Okay, it plays, but it doesn't stop. me test that. Okay, rewind works. Okay, wait. Stop doesn't work. Uh-oh. I hope I didn't break it. I have no clue what the bandwidth is. Okay. I will restart it again. I hope we didn't break the pin somehow. Oh, wait a second. I see what happened. The wire detached. Ah, fool. And that is a bad soldering job. Damn it. How do I... Okay. I need to bring the soldering iron. Yeah, that's a terrible solder job. Yeah, probably that. Oh, damn it. I'm terrible at soldering, peeps. Especially those magnet wire, those magnet wires are horrific. Botched soldering job. Yes. Okay. Let's fix it. Oh. I shouldn't be connected to the USB. It shows some sparks. Those strange voltage levels on the mains. Especially with this. Oh! Something's getting hot in here. I think I need a little bit more solder there. All right, good enough. It's a terrible solution and I love it. Without hot glue. All right, let's plug it in again. I hope I didn't break the link key because that was still attached when this abomination of a setup was tested. Okay, here we go. Connect tape drive. Okay. We need to power it up. It's just a wacky setup. Here we go. Now I will, am I connected? Yeah. Connect. Oh yeah. Wait. Oh. Okay. Connect. You can see the screen. Yeah. Is it my fault? Yeah, you can see it now. Okay. Play. And stop. And backwards. Switch directions. It's going down. Wait, let me give you a bigger screen though. Here. Let's stop it. Play. Oh wait. Yeah, I will set this up and we will continue, I don't know, maybe on Monday or on Wednesday. Peeps, I'm happy with the result. It took me longer than expected. I will leave for a little bit. No, you don't leave. I end the channel. Toshin! Look like Wizard Tech to me. Yeah, hello Toshin. First time. Chat. Thank you everyone. This is amazing. It works. I mean the control works. Now I will attach the ADC. I need to tinker around to find out which ports we can use on this board because the programmer board of the big thing, and then I could use different board like here. Because I made different boards in the past. Like one of those here from the matrices. It has like, I can access those things. I have the same MCU, USB. That's the programmer port. So probably this might be a better choice for interfacing. And I have plenty spares. So that's a good board. I will try to maybe use that instead, okay? Alright everyone. Oh, it also is a microphone and an ADC, a MEMS microphone here. And a speaker, so we actually could play back what we record there or whatever. Alright, this will be a nice stream. I was happy that we managed to do something. Let me stop it. Bloop. Thank you very much. We removed the recording of this session, YouTube session, here from the... Control it with the cluster. Open already. How do I open it? No, wait, this direction. Oh yeah, this direction. Here we go. This is the recording of today's session. I see you next time. Bye bye everyone. Have a good night.